Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Lilly Wurtz.
And my name is Annie Stocks Natalias.
And we're your hosts for episode 11, called The Chemistry Behind Diamonds. Today we will be discussing the structure of diamonds, as well as the main method used to create artificial diamonds, the high pressure, high temperature method.
So we're going to start with a little background on diamonds. They're made of elemental carbon and are what you call allotropes of carbon, just like graphite. So graphite and diamonds are made of the exact same thing, but their properties are the exact opposite of each other.
Yeah, in fact, diamond is the hardest known substance, while graphite is known to be extremely soft.
This is because of the way the carbon atoms are arranged. So in diamonds, they're arranged in a tetrahedral shape. This means that each carbon atom is covalently bonded to 4 other carbon atoms with bond angles of 109.5 degrees.
Yeah, just a little background on covalent bonds. So they involve the sharing of electrons so that the valence shell is satisfied, which is 8 electrons. The carbon forms 4 bonds because it wants to share 4 electrons to add to its already existing 4 electrons. So this pattern repeats, forming a 3D network of atoms, hence why it's called a covalent network solid. Graphite, however, it's only two-dimensional, a two-dimensional network solid. And so these differences in structure are what give diamond its strength and graphite its softness. This structure is somewhat difficult to picture in your head, so you can reference the diagram in the show notes if you would like.
Yeah, so what we think of when we say real diamonds actually formed billions of years ago, very deep in the Earth's mantle, and were somehow brought to the surface. So many scientists believe that they were brought up by a volcanic eruption that occurred millions of years ago, or even by the formation of Earth itself.
Real diamonds take so long to form, making them essentially non-renewable. While real diamonds take billions of years to form, synthetic diamonds or lab-grown diamonds can grow in just 1 week, but some take longer than 1 week. These diamonds, however, are not often used for jewelry, but rather used industrially and sometimes medically. In fact, over 98% of the demand for diamonds in industrial settings has been fulfilled with the creation of lab-grown diamonds.
Yeah, so their creation will allow their continued use for industrial and aesthetic purposes for many years to come.
However, the creation of synthetic diamonds are very different because we obviously don't have a billion years.
Yeah, so there are a few methods that people use to create them. These include high pressure, high temperature method, chemical vapor deposition, detonation of explosives, and ultrasound cavitation. But today we'll only be covering high pressure, high temperature as it's the most commonly used. So this method uses something called diamondoids.
And so essentially what diamondoids are they're just small pieces of diamond. And so they're only about 10 carbon atoms small, so extremely tiny. So you are essentially using an already existent diamond to create a larger one.
Yeah, so in the high pressure, high temperature method, the high pressure environment of the Earth's mantle is recreated in a lab. So in order to do this, a press is used.
I believe the 3 main designs are the belt press, cubic press, and the split sphere press.
Yeah, so you put the little diamondoids at the bottom of the press, and they're put into an environment of just pure carbon. The press is then heated up to about 1400 degrees Celsius, so super, super hot, and that melts a solvent metal. So a solvent is just a substance that another substance can be dissolved into. So the carbon dissolves into the solvent metal, making it a solute. The increasing pressure and heat increases the solubility of a solute, which is how much solute the solvent can hold.
So the reason you're able to dissolve the carbon into the metal is because of the strength of the various intermolecular forces. So adding heat and pressure adds so much energy that the intermolecular forces are overcome. And so this causes the particles to separate because the forces holding them together are weakened. So these weakened forces in both the carbon and the metal allow the solution to form.
So because the carbon is able to dissolve into the metal, it means that the solute-solvent attractions are stronger than both the solute-solute attractions and the solvent-solvent attractions. So this is what you would call an alloy, which is just a metal dissolved into another metal, but in this case, it's with a carbon dissolved into a metal. So this solution becomes supersaturated, meaning that the metal can't hold any more carbon. So then the carbon precipitates in the form of a crystal, growing the diamondoid. And that is how a lab-grown diamond is formed.
So these processes originally fascinated me because of the fact that you can condense sometimes multi-billion-year process into less than a week. And many diamonds found in the past and those used today can be dated back to the formation of the Earth, which is estimated to be, I believe, about 4.5 billion years ago. Just being able to recreate something formed by such a profound event as the creation of the Earth itself in a simple lab is just amazing to me.
Yeah, just the sheer amount of pressure and heat that's required to make diamonds in the Earth is difficult to even understand. And even though that synthetic diamonds haven't been widely adopted by jewelers, they look identical to the naked eye. I would not be able to tell the difference. And this is actually because they are chemically identical and are diamonds. So that's why using words real and fake aren't really true, because they are both real diamonds. One is just grown in a lab. Synthetic diamonds also last forever, which is the allure of diamonds in the first place.
Yeah, I believe some jewelers can't even tell the difference between lab-grown and real diamonds. And even diamonds themselves fascinate me because they aren't some complicated compound, but rather a different form of a single element. Just imagine the fact that graphite and diamonds are really the same thing, just in different forms.
We also chose to research diamonds and synthetic diamonds because they've been such an integral part of society. They're incredibly important in industrial settings, but also because of their use in engagement rings and jewelry.
We hope you enjoyed learning about diamonds. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.